as you came in today. So that will be your notes packet for this next unit. If memory serves me right, we are testing right before spring break. If memory serves me correct. Okay. Which is Thursday. Yeah, we'll do the Thursday beforehand. So, I believe that's the plan right now. Okay? We are going to hopefully not confuse you a ton today, but we're going to take your pre-calc angles and we're going to make them be navigation angles, and then we're going to have to use them as pre-calc angles when we get to it. Okay? All right? So here we go. Today we're going to start. It's in the textbook that we have this class based off of. It was section 4.8, but really we kind of combine it with chapter 6. Okay? So navigation, we're going to talk bearing and heading angles with a compass rose for a reference point. Okay? Here's where the confusion comes in. When we're talking about navigation and bearings and angles and headings and all of that stuff, 0 degrees is at the top. So this is 0 degrees, which is north. Which is different than pre-calc. Unit circle 0 is straight out to the right. Okay? Also confusing is that straight out to the right is east, and that is 90 degrees. So not only did we switch where the 0 is, we also switched the direction of the positive angles. Okay? So these angles, positive angles here now, are drawn counterclockwise. No, correction. That's regular clockwise. Unit circle is counterclockwise. I know. Guy can make one mistake. That's my one mistake for the day. Okay? Okay? Straight down would then be south. How many angles would south be? 180. To the left would be west, and that would be 270 degrees. Okay? So, let's go into some examples. These are all going to be bearing angles, if you will. Okay? Okay? So if I have a 53 degree bearing or a 53 degree heading, 0 is going to start up here. This angle right here is going to be 53 degrees. Well, we inverted it to get it to counterclock, to get it to clockwise, and then rotated it 90 degrees. Yeah. Okay. So let's talk 3 different types of angles here. So first off, we have the navigation angle. That would be 53 degrees. That's what was given. Okay. Yes? Yes. Okay. We can also have the trig angle for that one. What would the trig angle be for this particular angle? 37? Okay. The trig angle would start here and go back up. So this would be 37 degrees for a trig angle. Yeah. We also have a reference angle for it. Reference angles, remember, closest, we got to get to the closest horizontal. How many degrees to get to the closest horizontal? 37 on that one also. Yes, sir.
What's the point of a reference angle? What would you use it for?
Because we're going to have to find reference angles based off of certain distances. And so we always go with the reference angle because then we don't have to worry about negative angles and we get the acute angle that it's in that particular quadrant. But in quadrant 1, the angle is just the reference angle, or the complement of the bearing angle. Okay? But that's not always the case. That just happens in quadrant number 1. Okay? Let's switch to 195 degrees here now. Which quadrant would 195 degrees be in? Quadrant 3. Closer to the vertical of quadrant 3 or closer to the horizontal of quadrant 3? Closer to the vertical, so somewhere down in here. So this angle right here is 195 degrees. That is my, my navigation angle is 195 degrees. Okay. What is my trig angle? $255? Because I would start here and I have to come all the way around here. That would give me 255 degrees. What was that? Well, see, I knew that this angle in here was 15 degrees. Right? So 270 is straight down on the unit circle. So I went 270 minus 15 is how I did. I don't know if that's how Muddles did it or not. That's what I did. What would the reference angle be for this one? Reference angle, back to the closest horizontal. 75? Yep. 75, and the reference angle would be right there. Okay? So we've got 3 ways to name the same angle. We've got its navigational name, we've got its trig name, and we've got its reference angle name. Tomorrow, we'll learn a 4th way to navigate with another way for the angle. What I'd like you to do right now is I would like you to try these next two. Find me the navigation angle, find me the trig angle, and find me the reference angle for those two. So I got a navigation angle of 300 degrees. That one was given to us, obviously. And then I've got a trig angle of 150 degrees and a reference angle of 30 degrees. Yes? $127 degrees would be somewhere down in here. Right there would be 127 degrees. That would give me a reference angle here of 37 degrees. That would give me a trig angle here of 323 degrees. Yes. Questions, comments, concerns, clarifications? None? Let's go sail a ship out of Florida then. Lena, don't pick on me. We used a picture of a sailboat, but then called it a speedboat. Okay? All right? Okay? All right? Okay? A speedboat travels at a speed of 40 knots from Fort Lauderdale on a course of 65 degrees for 2 hours. Then it changes its course to a course of 155 degrees for 4 hours. We need to determine the distance and the bearing from Fort Lauderdale. Okay? So, first off, there's a couple of probably newer words for you in here. The first probably newer word for you is knots. Okay? Knots is nautical miles per hour. Okay? So a knot is a nautical mile per hour. That's our second word then, is nautical miles. Well, what a nautical mile is a 1 nautical mile. Now I got to remember on this one. 1 nautical mile is 1 minute of the Earth's circumference. A nautical mile is slightly longer than the standard mile we use in our daily lives. Okay? Or not. Get out of there. Okay? It's based on the Earth's 1 nautical mile corresponds to 1 minute of latitude. So if you take the equator of the Earth and make that be your circle, okay, it's got how many degrees? 360 degrees around there, right? Each degree has how many minutes in it? 60 minutes in it, right? So 1 nautical mile is 1/60th of 1/360th of the Earth's equator. Okay? Which equates to about 1.1508 land miles. Okay? They did that way back in the olden days because they knew they had 360 degrees around the circle, and so they needed to have a standard measurement system for everyone, so that's why they went with them. Okay? And so that's what a nautical mile is. So a knot, when you hear a ship saying that it's traveling at 30 knots, it's traveling at 30 nautical miles per hour. Okay? All right, so let's start here with, we've got my pen back. We are here in Fort Lauderdale, right there. 40 knots, it's traveling on a course of 65 degrees. So I got to make myself a little, I don't want to call it a bullseye, we call it a little compass. Okay, we'll go with compass. Okay, I got to make myself a little compass at there. And I got to get a 65 degree angle coming out of there. Agree with that? Okay. So this angle right here is 65 degrees. It travels on that course for 2 hours. So how far did it travel? Nope. What is the length of that side? Or of that line segment? It's what, Leah? It's 80, right? It's traveling at 40 knots, which is nautical miles per hour, for 2 hours. So how far did it go? 80 nautical miles. The symbol for nautical miles is NM, literally for nautical miles. Okay. Then it changes course. So now I've got to draw another compass here, and it changes to a course of 155 degrees. That's going to be down there. Where this angle here is 155 degrees. And it stayed traveling for 4 hours. So how long is that side? What do you got? That's 160 nautical miles. We need to determine the bearing and the distance from Fort Lauderdale to the boat. Well, let's find one. What do we got? Talk to me. Which angle do we know?
65.
Okay. We know a couple of angles on the inside.
Oh, it'd be the reference angle of 60. No, it wouldn't.
No, because this isn't straight horizontal. Yep. I like that though.
Wait, if these are parallel, wouldn't 65 be the inside of the top?
Right here?
Yeah. It'd be that.
Yep.
Then yeah, that's 155. So it'd be like what? 25 away from.
25 right here?
Yeah.
Yes? So that would be a whole, that's 90 degrees right here. That helps because now we got a right triangle, right? Okay, so now that we have a right triangle, can we find the distance? Okay, how am I going to find the distance? What do you got? Pythagorean theorem. So the distance squared is going to be 80 squared plus 160 squared. So 80 squared is 6,400. 160 squared is 25,600. All told, that gives us 32,000. So the distance is going to be 178.88544 nautical miles. Would you agree with that?
Yes.
Okay. What we need to find, so we found the distance, okay? We got the distance. We're good there. What we need to find now is we need to find this angle right here, because that's going to be our bearing from Fort Lauderdale to the boat, which is it's navigation. Bearing, heading, navigation, all three ways of saying the exact same thing. That's different. The kicker here, you're going to laugh at me when I say this, but the most important word in this last sentence is the word from. Okay? Because the bearing is different from Fort Lauderdale to the boat than it is from the boat to Fort Lauderdale. Okay? They are different angles. Okay? And what would that get me? But which angle would that get me?
That would be inside.
We can find, since we've got a right triangle, we can find the inverse tangent of this angle right here.
Yeah.
Because then we can add 65 to it. I like where your head's at. Yep. Okay. So let's call this angle here theta. So the tangent of theta is going to be what?
Because that would be the other side. Like that would be the outside of this far angle across the horizontal. Where the boat is. Because if these are on the same plane.
This wouldn't show up anywhere over here.
No, but I'm talking about this inside tangent angle. Wouldn't it be? It couldn't.
Well, let's find it. Let's find it first, and then we'll figure that out. Okay. Okay. So what do we got? Tangent of 160 over 80, which is the tangent of 2. So that means that theta then is going to be the inverse tangent of 2. Yes, bless you. What is the inverse tangent of 2?
63.4.
What are you scoffing at me for? This is just a calculator. This has nothing to do with today. Yeah, you just have to literally go inverse tangent 2 equals. Yeah. And then what now? And then because now we want the bearing, right? Or the navigation, or the heading. It's all just different ways of saying the exact same thing. It's just the angle. Yep. Okay. So you're saying that that's going to be 65 degrees plus this 63.435 degree, right? So that's going to give me a bearing then of 3 is a great number. Yep. So that would be what? 128.435? Navigation angle. So that's 0 at the top, going clockwise. For all, so pencils down, eyes up here for 1 second. Okay? For all of your calculations, you use trig angles. For your answer, you use navigation angles, which is why we had to learn this stuff first. Okay? So this is what your answer is going to come, this is what the question's going to come in, this is what your answer is going to leave in. In between, you use these two. Okay? Right? A 300-degree bearing doesn't mean you just type in 300 degrees on your calculator, sine, cosine, tangent, whatever you want. Okay? You got to convert that over into a trig angle in order to use your calculator.
Didn't we start on 65 and with the navigation angle? What's the answer in? Did it start?
No, this trig angle is 25 degrees.
But we never used 25 degrees.
We didn't have to because we didn't need to use that there. We had nothing to do with that. That 25 degrees is only this little sliver right in here. There's still that extra part to go yet. We use 65 up here because north-south is parallel, cut by a transversal, means that they're alternate interior angles. This angle just happened to be 25 degrees because we turned to a course of 155 degrees. We made it nice for you for your first one.
So if it wasn't nice,
Then you'd have to use law sines
no, but like
or law cosine.
But for the how you made the navigation angle, or that was 65, and then you did the same angle where it was 65. Wouldn't that be not actually? Wouldn't that be 25 in the trig?
No, 150. This 155 would be, so this would be 295 in trig.
So how could you use that in? Oh, because you didn't use trig.
Because we went to this triangle where it was, this angle was 90 degrees. Yep, good questions all around. Yep.
So when you use tangent on that right triangle,
Yep.
you get that other 90 degree. Would that cause trig? Would that cause
Yep.
a trig angle?
Yep. So this angle in here is a math angle, is a trig angle.
But then the 65 is.
But then we had to add the 65 to it to get the bearing, because the bearing starts up here at north and comes down this way. So we have to go through the 65 degree angle, then through the 63 degree angle to get to the bearing.
But you can combine those two, even though one's a navigational one and one's a trig one.
Yes, because they're still both angles.
Okay.
Yeah.
Oh, this is kind of like total amount of degrees. And then you just
Go for it. So there is one very important word that you might have glossed over in this, and that is the word. Come on back to me. That is the word from. Okay? So the bearing from the 2 points is that. Okay? So let's come up with our 2 points.
You should put it anywhere on the shoreline.
Well, hopefully we put them in the right spot. So if I put my first point up there, then the bearing to the boat is going to be this one. Yes?
Oh, yeah.
Okay? If I put my other point here, then the bearing to the boat is there. Which one, top or bottom, has a bigger bearing? The bottom one, right? Because it has a bigger angle to get to the boat. So that means then that this is the 240 degree bearing, and this is the 260 degree bearing. So that means that this angle here then is 240. This angle here then is 260. Which means that this angle here then is how much?
Trig values, or is this the one we have to find the trig?
It's an angle. This is a math angle, so it's a trig angle. How big is that angle? 60 degrees. 180 to here, 60 more gets me to 240. How big of an angle is that angle? I didn't really get dotted there. Because it's not inside my triangle. How big of an angle is that one? That's 80. Which means that this angle here is 100 degrees. Which means the angle to the ship is 20 degrees down here. We know that these points are 300 feet apart. Yes? Okay? We want to know how far the boat is from shore. Which means we want to know that distance right there. We need to solve for x. Okay? Now go for it.
Well, this is still 6. Okay. So if you think here, this one's going to here. So to find this, use this angle. So then side angle here, this side. We can use this. You can use this 60. We need that angle. We need a side.
Oh, yeah.
See, I don't like it just because like, no. And I'm not going to find the same one.
the outfield wall is an arc.
Yeah.
So it looks like an ice cream cone. So we've got 300 sines of 60 divided by the sines of 20. We're going to store that as our y, and that's going to be okay. So we're there, yes? Now you could have also solved for the big to go up way up to the top, but that's fine. What I'm saying is you could have solved for this one if you wanted to, but it really wouldn't have mattered. Okay, you'd still get the same answer in the end. So then we know that this angle here is 10 degrees. So then we can say here that I've got cosine of 10 degrees is equal to the adjacent side x, which I'm looking for, all over y, which I have stored on my calculator as my answer. It's the 759.627 number. So x here is going to equal y, which is the answer on my calculator, times the cosine of 10 degrees. So really all I have to do is multiply by the cosine of 10 degrees, and I get here that the ship is, or the boat, this isn't a ship, this is a boat. Buy me a boat. The boat is 748.086 feet from shore.
That's not how I did.
Yeah, but you just do the left side.
Couldn't you just do the sine of 80?
He's saying it's more work.
Instead of finding the cosine of 10.
Sine of 80 equals x over y is the same thing. Yep. You'll get the same answer. Okay.